This video will show you how to use the Polar Speedstack Stackup Builder in conjunction with CGen coupon generator to generate controlled impedance coupons. You will notice that inside the Speedstack Stackup Builder we have a 10-layer stackup, and looking on the right hand side of the screen we can review the controlled impedance structures that have been added to this stack. So you'll notice that there are 8 structures, controlled impedance structures, and if we just quickly browse through, you'll notice that there's a 50 ohm structure on layer 1 and a 100 ohm structure on layer 1. Moving down to layer 4 on the stack up, highlighted in blue here, we have a 50 ohm and a 100 ohm structure on layers 4. Quickly browsing down through, structures 5 and 6 are a 50 ohm and a 100 ohm structure on layer 7, and also finally, because this is a symmetrical build, we have the same 50 ohm and 100 ohm structure on the bottom layer, layer 10. We want to quickly review the structure arrangement on this stack up. We can slide the stack up to the right and you can see the structure view image to the right of the stack up. This was a new introduction into Speedstack 2023, and this gives you a brief overview of all the structures that you have on the stack up in a quick view to the right hand side. You can even click on the structures to review each one of those if you need to, and this will highlight the relevant layers on the stack up. So in this case we have a structure on layer 1 which references layer 3. So layer 1 is highlighted in blue, and you can see that the layers that affect this impedance structure are actually highlighted on the stack up. So that's a quick review of the structures inside Speedstack. So how do we create a coupon from this point? Well, what we need to generate a coupon is to take the stack up information and the impedance structure data across to our Polar coupon generator product. So to do that, we can use the file menu, export coupon generator, bracket CGen there to let you know the product that we're going to export the data to. Now at that point what we've done is we've taken the key aspects of the stack up and the impedance structures and placed them on the clipboard. If we now open up CGen, we start with a blank screen, but the first thing we need to do is to import the data that we've just exported from Speedstack. So we can go to the import, we select the Speedstack clipboard format data, and what we will see here is the stack up loaded in the left hand portion of the CGen screen. Notice the 10 layers, and then we also have impedance structures for the layer that is currently highlighted in blue. What we also have is a validation screen which actually checks whether the structures are valid for the particular coupon we're going to generate, and I'll explain that in a moment. If we close the validation screen, we can review the structures. So if we come down on the left hand side of the stack up, we can look at layer 4, and you'll notice that we have strip line structures on layer 4, whereas on layer 1 we have microstrip structures, because of course they're surface structures. Layer 7, we also have strip line structures because we have reference planes above and below the trace layers. And finally on layer 10 we have coated microstrip structures because they're referencing just layer 8. If we now move to this stage and generate a coupon, what we can do is use the generate coupon option here and choose the coupon style. CGen has a number of coupon styles which allows you to vary the launch footprints and the length of the coupon depending on what probes that you have available with your Polar CITS instrument. In this case we're going to go for style 2, and you'll notice that on clicking that we have an image of a coupon that's drawn in the main window. Notice that as we zoom in, we're currently looking at layer 1 of the coupon. This is obviously the top side, and here we have the text indicating the layer that we have for each test structure on the coupon, and also whether it's a differential coupon or not by looking at whether we've got a separation parameter. So in the case of structure 2, it's a differential. You can see it tracking upwards there. We have a pair of traces, and the separation between those traces is actually the S1 parameter there. The trace widths being used are the W1 parameter on the coupon. If we browse through the coupon, we can look at the reference plane on layer 3, and obviously on the layer 3 there is a reference plane for all structures that are on layers 1 and 2, but also on layer 4. So if we then switch to layer 4 on the structure, we can have a look and see the offset strip line structures that we have here. Now you can also click on the structure inside CGen, and that will highlight the actual trace that we're looking at, or the structure that we're looking at in terms of the launch pads and the trace widths and separations in blue. Just quickly flipping back to the structure validation option, when you click on there, that option here, and this is what we saw when we imported the data initially, this will check to make sure that the structures that are actually located on each of the electrical layers of the coupon have the right reference definitions. So in this case, as we browse through, all the structures are in green, all of them are okay, so all 8 structures that we passed across on Speedstack will be created correctly on the coupon. If, for instance, we had the layer definitions incorrectly specified, so in this case I've switched the plane that was originally, the reference plane originally on layer 3 to a signal layer. Now what we're seeing is a check report warning. Clicking on there, we can now see that these are the structures that are no longer valid, because if you look at the reference plane on layer 3, or the reference plane that should be on layer 3, because it's now indicated as a signal layer, those structures will be highlighted in red. So to resolve that problem before we generate the coupon to be placed on the manufacturing panel, we can just switch the layer to the relevant type. So I'm switching it back to reference plane. Now the flashing red indicator disappears, and again we can generate the coupon correctly. Just looking at browsing through a couple of the coupon styles, if I switch to style 3, what we have here is an alternative footprint, so a similar arrangement of structures but actually with a different launch footprint. In this case the ground pins are in referenced by squares, and the signal pins are circles, but you'll notice that the ground pins are offset, whereas style 2, they're in line. Once the coupon has been generated and everything is looking good, what we can do is export the data to a number of formats. Certainly the Gerber format is the most common one, where once we export the Gerber for each of the electrical layers of the coupon, that can be imported on your cam station and placed on the manufacturing panel, so that you have the coupon alongside the actual printed circuits that you're manufacturing. And also you can export a CITS test file, and what that will allow you to do is it will output the 8 structures as a test list in your for the Polar CITS instrument. So once the manufactured coupons are complete, you can use that test program on the CITS to test the coupons. The labeling and the structure numbering and ordering will be matching the coupon that we've generated inside CGen. So it's quite a package of data which allows you to manufacture the test coupons and also physically test those coupons at the end of the manufacturing process. I hope you enjoyed this brief video on Speedstack and CGen, and I look forward to speaking to you again soon.